Smith & Associates is a firm located in Unionville. Recently, a team conducted an audit for a discount chain. One part of the audit involved developing an estimate for the mean dollar error in total charges that occurred during the checkout process. They wish to develop a 90% confidence interval estimate for the population mean. In this case, the population consists of error made in customers' bills at the discount change store in a given week. A sample random of 20 is selected with the following data. You can see below this 20, once more, error made in customers' bill at that chain store in the given week. Positive values indicate that the customer was overcharged. So I put all the data into a column. Let's calculate first the mean in order to calculate the 90% confidence interval estimate for the mean. So I'll calculate the mean of this sample of 20 customers. I like to have the value of the mean in this cell, which is D12. I'm going in statistical functions. I'm looking for, let's put first statistical functions, and I'm looking for average. So the average is 0.775. Let's calculate the standard deviation of this sample. Similar, I'm going in statistical functions. I'm going to standard deviation. This is for population and S is for sample. We have a sample, so I'll check standard deviation for sample. The input is from 812 to 831. And this is the standard deviation. If I like to calculate the t-critical value, we have also the possibility. I'm going and I'll check t inverse 2t. They will ask me for probability. We have a 90% confidence interval, so probability is 10%, so decimal 10. Comma, degrees of freedom. We have 20 customers, so 20 minus 1, we have 19 degrees of freedom. And this is t-critical, the same that we read from the t-table. Now we are looking to calculate the error. So similar, I'll go in formula bar, confidence not normal this time because we have a small sample with standard deviation of population not given. We are using a t-distribution. So I'm looking for confidence t. Now they ask for alpha, decimal 10, comma, standard deviation. We have 1.196 standard deviation, comma, and we have the sample size 20. So once more, here we have the sample size and we do not have the number of degrees of freedom. So this is the standard error, the same that we had with algebraic method. So I'll try to reduce this one to less decimals. Now, when we calculate the lower limit, will be the mean for our sample minus the margin error. So I'm going in formula bar, the mean minus the margin error. The upper limit will be the mean of our sample plus the margin error. So decimal 31 to 124, it's a 90% confidence interval for the true mean of dollar error in total charges for all customers' bill at the discount chain store in a given week.